this video, I will show you how to do the basic regression analysis, which will be used in this assignment. I may introduce some advanced regression analysis techniques in another video. To be able to do the analysis in Excel, we have to do some setup first. In Excel, click File menu first. Then click Options. In this window, click Add-ins. And here, Manage Excel Add-ins, click Go. And here, you will find some options. You should check Analysis Toolpack and Analysis Toolpack VBA, and then click OK. After you have done so, click the Data menu. Here you will find the Data Analysis button. Next, we'll do Regression. Click Data Analysis, and here choose Regression. Click OK. And here in this window, click here. Click the blank window to choose the dependent variable. So here I choose this column as the dependent variable, and click this blank to choose the independent variables. So I choose the four variables as the independent variables, because as you can see, this dataset has variable names, so we must check the labels option, and for this assignment we leave the rest of the options unchecked. Then click OK. This is the output of the regression analysis. For this assignment, we only focus on the R square. So here I highlight, and this window. We can delete the irrelevant outputs. So here we delete these columns, and delete the two columns, and also we delete a Nova table. Okay, here next let's interpret the output. R squared basically tells you how good your model is. R squared can tell you how much the variation of the dependent variable can be explained by your model. So R squared is a value between 0 to 1. The higher, the better. So usually, if your R squared value is higher than 0.1, your model is acceptable. In this table, the coefficients tell you the magnitude and the directions of the effects of the independent variables. So in the first row of the table, this is the effect of the intercept. We don't care about the effect of intercept. These are the effects of the four independent variables. So here, the sex and education level have a negative relationship with the dependent variable. And next, the most important thing is to look at the p-value column. P-value tells you whether or not the effect is significant. In other words, whether or not these effects are real. How to tell? If the p-value is less than 0.05, that means the effect is real. Instead, if the p-value is higher than 0.05, that means this effect is due to chance or is not real. So when you interpret the results, you first look at the p-value to find the significant effects of the independent variables. In this example, all the effects of the independent variables are not significant. But in your case, you probably will find some significant effects if the p-value is less than 0.05. Let's do a wrap-up for this video tutorial. In this analysis, all the effects were not significant. In order to get you familiarized with the interpretation of the results, I next make some changes. I changed the p-value of the independent variable age to 0.03. I changed the p-value of education to 0.001. Okay, after the changes, the p-values of the two independent variables were less than 0.05. In your assignment, don't make any such changes. This is just for illustration purpose. If you make changes on your results, that's fabrication and plagiarism. Because the age here is significant because p-value is less than 0.05. So, and the coefficient of age is positive. So the age has a positive effect on the dependent variable liking. However, the independent variable education has a negative effect on the dependent variable liking, because here the coefficient of education is negative. So this means the higher the education level is, the lower the liking is.